my name is Ella Castelloe, and my project has been to develop a method for finding galaxy groups like our own out in the universe. So first, what is a galaxy and what is a galaxy group? A galaxy is a bunch of stars and gas that are surrounded by a halo of dark matter in a sphere around the galaxy. And there's different possible definitions of a galaxy group. Perhaps the most common definition is what we call a settled group, which is all of the galaxies that share a common dark matter halo together. But the local group, which is the group that we live in, which has the Milky Way, which is our galaxy, and Andromeda, which is our giant neighbor, and a bunch of smaller galaxies, the local group is actually not a settled group because the Milky Way and Andromeda live in different dark matter halos. But they are gravitationally bound, and eventually the local group will evolve into a settled group. So most group finding methods find settled groups, but we are interested in finding groups like the local group that are in the early stages of formation. So we have created a new method that finds groups like the local group out in the universe. So this method is called the boundness method, and the way it works is there's two settled groups that we're testing for gravitational boundness, and we calculate the speed that those groups are moving away from each other at, and we calculate the speed that one group would have to be moving to overcome the gravity of the other group, which is called the escape velocity. If the groups are moving away from each other at a speed that is less than the escape velocity, then they aren't moving away fast enough to overcome the escape velocity, and the two groups are gravitationally bound. And if two groups are gravitationally bound, we call them a bound multigroup system. So here are two examples, one of a bound multigroup system and one of a settled group, and the points are galaxies and the circles are an approximation of the dark matter halos. And you can see in a settled group, there's just one dark matter halo with a lot of galaxies inside of it, but in a bound multigroup system, there are multiple dark matter halos, and all of the galaxies in the bound multigroup system are gravitationally bound, but not all inside of the same dark matter halo. So we wanted a method that would find groups like the local group, and to test whether the boundness method does indeed find groups like the local group, we identified a population of local group analogs. Local group analogs have a Milky Way analog and an Andromeda analog, and we require those two galaxies to have similar masses and separations to the real Milky Way and Andromeda, and for them to be bound to each other and not bound to any other giant galaxies. So the local group, the real local group, is somewhat isolated from other nearby large groups, and so we require the same of our local group analogs. And we use simulated three-dimensional information that we can't observe in the real universe to identify a population of true local group analogs. And then we use simulated observational data, like what we actually do observe, to test how well the boundness method finds these true local group analogs. And it turned out that the boundness method found 97% of the true local group analogs, and a settled group finder only found about 6%. So this confirmed for us that the boundness method does do a good job of finding groups like the local group. So now for a few other findings, we found that about a quarter of all galaxies we studied are members of our group in the early stages of formation, and about 6% of all galaxies we studied are members of a local group analog. And overall, the boundness method is successful at finding groups like the local group. So now that we have the boundness method, we can use it to learn about galaxy groups like our own in the real universe. And we can also use it to compare groups at different stages of formation to learn about how groups change over time as they evolve. So that is all. Thank you for listening to my lightning talk.